Hey, welcome back. So we're at Devoxx Belgium still for the rest of the week, so that's going to be good. And we're today with Angelos, or we're going to be now, I should say, with Angelos Bimpoudis.
Hello, everyone.
Yeah, nice so Angelos, we're going to talk about pattern matching, but before we get there, Angelos, for the people who don't know you, and that might be actually quite a few, you're one of the up-and-coming stars in OpenJDK. Tell us a little bit about yourself.
Thank you for the invitation, first of all, and the introduction. My name is Angelos Bimpoudis. I have been working with the Java platform group for the past 3 years at Oracle in Zurich. I was involved with the rest of the team members on the design and implementation of unnamed patterns and variables, and that was delivered in the previous iteration. And now we have a new preview feature about pattern matching and a little bit about the rest of the language that is about primitive types in patterns and suites and instance of.
Okay, nice. You have a talk here that covers the past, present, and future of pattern matching. That talk is like 50 minutes long. We don't have that much, but maybe give us like a little bit of a tour. So what about the past, for example, would you find interesting to tell people?
Yeah, sure. So maybe I will start a little bit from the present and what we have.
We're going to do like asynchronously?
Yeah, asynchronously to confuse us. No. So here there's a really beautiful story.
Yeah.
And there are two angles to say this, two directions to say this story. What we have now and how we are planning to improve.
Yeah.
And then how this affects the principles, or starts from the principles and build up.
Okay.
But let's give a brief overview of the past and the present.
Yeah.
So in the beginning, like prior to pattern matching, we had to be a little bit more descriptive and algorithmic to describe our introspection of data. So we had to ensure safety of our programs. Like if we want to take a record class apart, we had to say, give me my first component, is this like of type point, then cast it, then extract, then like, it's like, step by step. But then patterns come, and then we can be more intentional. We can be more, okay? The code becomes clearer for the reader, and the intention is more clearly like coded by the developer.
Yeah, I just need like the one thing to impress the intent, whereas before it was, is it that type variables, extractors, I need like several statements intentionally.
Exactly. Now, like we are describing intent of an algorithm.
Yeah, that makes sense.
We are describing intent declaratively.
Yeah.
And actually, we're describing the shape of the data that we want to pattern match over. So in the beginning, we had instance of, which is like a type comparison operator. And that was, and still is, safeguarding casts, the cast conversions. So people do, is instance of string? Is this object instance of a string? Is this instance of a person? Like, continue. And then patterns were introduced in the form of type patterns. So you could do, is object instance of person P?
Yeah.
So then you get the test, the conditional query, at once. You get the conditional query at once, you get the casting, you get the name, this P, like the initialization of my data, you get it very concisely. So type patterns describe an idiom, let's say, that embeds safety in the language. And then we have suites that is also revamped to start accommodating like this like new philosophy. Like we have switch expressions, then switch was enhanced to accommodate type patterns, and then record patterns come.
Yeah.
That are essentially the equivalent of record classes. And here we are in a very beautiful checkpoint of like data-oriented programming.
I always describe that as like the pattern matching basics, right? We have a powerful switch that can do this exhaustive check. We have the CL types that we need for that. We can pattern match against types and take things apart. And then unnamed patterns also. Once we have all of that, we can really start using this reliably in practice. And from there on, we can build it up and build it out, as I described it.
So with unnamed patterns and variables, and then the unnamed pattern variables, like these are the three elements of unnamed, the unnamed work that we did. We have a very nice way to declare again our intent, also declare what we don't want to use, like during pattern matching. So I want a color point of a point that I don't care about the y coordinate. I care about the x, and I care about the color. Like, and it's like beautifully, even verbalized beautifully. Like I like the reader is like pleasant to understand the code.
Yeah, I agree. And what I like about that, then also you can use guarded pattern with the when. What I like about that is that when you read a switch, on the left-hand side of the arrow, you can see what data is interesting here. Exactly. As you said, I only care of the colored point, only care about the color and the X, and then maybe only when the X is positive or something. And so left-hand side, I look down the switch, I see like, so this is the data that is being extracted. And on the right-hand side, I can then look at what's being done with it. And often when you look for where to put a feature, where a bug is hiding, the separation really helps because you can see, like, okay, so what data is being extracted? Oh, here's the thing that I think where the bug is hiding. Here's this is extracted. So probably that is the right-hand side I need to look at. So it's like a very clear separation of what am I working on? And then on the other side, how am I processing it?
Oh, this is beautiful. I mean, you described everything. So, and here, like, I will plug this exhaustiveness into that, because exhaustiveness really works for the service of the developer. It's like the compiler is telling you, hey, you need to handle more cases because you are not handling all cases. As you said, like, we have sealed classes. We have also enums that are all about values. So a little bit, we have compile time knowledge about what, like, the whole of our domain is there. And then with records, we have compositionality in this axis. So, and with sealed classes and enums in another axis. So all of this composed, and when we work with a switch expression or statement, and we have exhaustiveness, like, we could have a tricky situation where we don't handle something, but exhaustiveness ensures that we are going to get a compile time error if, with the compile time knowledge that the compiler has at that point, the program is exhaustive or not.
So there's clearly room.
That's the present situation. In short.
So there's still clearly room for situations where I'm like, I do a switch and I know, well, this isn't supposed to happen. But then you can still throw like the the illegal state exception or something, for example. But you have to. Like, it's not something that you can quietly just ignore and be like, this can't happen in practice. Not the compiler will tell you. Like, you need to handle it though.
And somebody may say, hey, I can write default. No.
That's the point.
The compiler, the exhaustiveness is not there to save us from typing default or something. Why is that? Why did I emphasize compile time knowledge all the time? Because if I write, I want my record, my point, like my colored object, and then default, and then I think I've handled everything.
I mean, you did handle everything.
Yeah. So I handle everything, and then I have a default. Then what happens if somebody introduces new variants in the program? The client code does not recompile the code, so errors can be swept like under the rug. But if you rely on exhaustiveness, and then you handle all your cases with and the switch is exhaustive, and then you run the program, the compiler will put a synthetic default. And this is not just to save us from like typing characters. It's like for runtime to be able to handle these novel types. So these are now not compile time knowledge. This is runtime knowledge. And there is a synergy, like the translation of switch with the runtime, and the exception that we will get in a new type that was unknown during the execution. So there's a synergy for safety.
So what you're saying, party, is that if I write a default branch manually, then future changes of the code may end up in that default branch without you wanting it, but you don't know, because the default branch that you wrote maybe does something, some default action, and then you default action for something that you actually wouldn't want it to. Whereas the default branch that the compiler puts in just goes, right? You just get your program tells you there's a new case here.
So we, developers and everybody, should reduce this as much as possible.
You can all the cases, and when you want default behavior, use that.
Also. So this sums up the present.
Okay, so we get to the future. I think we already have a question. I want to get that one out, so we make sure that we cover those. What is your tip for learning programming languages like Java? What would you do if you were total beginners? Okay, that's like a little bit further away from the topic than we actually intended. But there's a little bit of here maybe that we can talk about when you would teach Java or when you would think back about how you learned Java. Where there would you put data on the programming? Because the thing, or like just the general say like pattern matching. Because the thing is, for somebody who's a seasoned Java developer, they know a lot about Java, and then pattern matching comes at the end because that's like we already know.
Yes.
We know everything about Java. We don't, but we have a like firm understanding of Java, and then pattern matching is the last thing we learn. And so I think it's easy to consider this as kind of like a late topic to teach, but I don't think that's the case, right? I think like there's an argument to make the pattern matching is not something that you would learn after everything else.
Yeah.
Actually, kind of like it's a core part of Java.
It is like data introspection has been there from the very beginning.
Yeah.
Okay. And actually improving like the way that we deconstruct our data.
Yeah.
And making the ways to deconstruct our data easier to write.
Yeah.
It actually helps people to learn, because if the reader is helped, like the day-to-day programmer is assisted by a new feature, even the newcomer is going to be assisted.
Yeah.
So when data comes from the world in the form of JSON-like file, and then you have already through a library an automatic way to have a structure like in memory, and then you want to deconstruct it. I mean, you're as a newcomer, even you're 2 steps like away from doing something very useful, like a to pattern match over a JSON value, and then like take the extract.
Yeah.
Like so. I mean, now philosophically and outside of like pattern matching, what's the best way? It's like to just just code, just
It's like if you have a teacher, like what order would that pick? And I actually think that pattern matching has the advantage. So as you said, like it really helps with dealing with data in a very concise but also expressive way. And I think that beginners, like what would you do like as a beginner? You're not going to write like, if you have like a project, say just do. If you want to have like a small project as a beginner, you're not going to write a backend that does, I don't know, financials or so it has like a big domain logic where you have like lots of things. And what you want to do is probably stuff on your machine, like maybe read a CSV file, parse some JSON.
Exactly.
So I actually think beginner tasks are often more data-centric just because they're using something that's on their hard drive maybe or comes from the web.
Exactly.
And then being able to deal with that data expressively and concisely and safely is a good first thing to learn. And maybe do the whole, I don't know, how to do like full-blown object orientation, for example, or how to write complicated domain logic, and all of that, can actually come later. I think there's an argument to be made that this helps with the first tasks of programming, actually.
Yes. Yeah. And it should be goal-oriented, as you said, a small project, like they're crunching a little bit of data from a file, from like a web service, and then like introspecting, taking some decision and helping my everyday life.
Yeah, exactly.
And like switch, the switch statement is there, like in the beginning, like you're going to need it.
Yeah,
of course you will pass through if then else. First, it's like what everybody like.
Yeah, but also like so that's really interesting. We talk about exhaustiveness, and I think that's really important. But when you think about instance of type checks, people might think like, oh, switch that says case this type, case that type. That's just like a long if then else chain. But really, this exhaustiveness part is so like it's not only syntactic sugar. This check of did you cover all cases is something that only works for switch naturally.
Yes.
And that is essential to this. So it's not just like, oh, if it's this type or if it's that type, and otherwise I don't know what to do. That looks similar, but it's much unsafer.
Yes. In the beginning, do we have 30 seconds? More like
in the
beginning suite was not used a lot for like general purpose programming. Like it had like these like scoping rule and fall through, so it was very good at describing state machines and tokenizers and stuff like that,
which is what was used for, right?
And then like this mental model of having like each case handling something and producing an equivalent number of results was not there.
Yeah.
And that like a few years ago, this was like improved with switch expressions, right? Every case should return then exhaustiveness, like it was part of the story, and everything. And instance of was like a one-way type comparison, and then it became one-way like primitive operator, like pattern matching operator.
Yeah.
But with switch, you have this now holistic like view of processing.
Yeah. Okay, so we talked about the past and the present. We got like a couple more minutes. Give us, pick one thing from the future block. There must be like when you talk about, I mean, at least that's in the title. So I assume you're going to talk about what's coming.
Yeah.
Can you pick one of those and tell us about that?
Look, I wanted to talk to you about primitive types in patterns in instance of and switch.
That's the current preview, right?
That's the current preview, and there is a wonderful story to be told there.
Yeah.
But I will tell you a little bit further than that because I know that you like future. Future. Okay.
So if you're interested in that part, I gave a talk here, a deep dive session about Java 22 and 23, and there was like a 2.5-hour session that is maybe already on YouTube on the Devoxx YouTube channel. I guess it will also be on the Java YouTube channel at some point. In that massive 2.5 hours, somewhere towards the end, I'm going like I think in the last hour. I'm going to over primitive patterns, and those are good. So, and Angelos was in the audience, and he didn't throw rotten eggs at me, so it must have been okay. So go watch that and give us something new then.
I really, by the way, I really liked your presentation. The idea was that we are dropping restrictions that were existing about primitive types, and now like there is like a complete story that fuses primitives and references, and you described it perfectly. So
thank you.
Very good. So now there is this thing about composition. Constructors compose, right?
Yes.
So we can create a new colored object of a new point of 1,2, passing like a color. It's readable. With record patterns, record classes, you see, like this is like constructing record classes or classes, like construction composers. For pattern matching, we get beautiful composition for pattern matching as well with record patterns.
Yeah.
You can have the same thing, and it's actually very readable. I want a colored object of a point of x, comma, whatever, I don't care, underscore, comma, any color. Composes. Nested patterns inside record patterns, and it's beautiful.
So you can take it apart the same way you can put it together.
Exactly.
Yeah, okay.
So the future that we are heading is to make deconstruction and extraction of data principle the same way that we have our record basically. So
like a class, just
regular class.
I can take that apart.
I take that apart. So now we have a semi-principled approach, getters, but this gives us no guarantees which getters are going to be there, how are their names, etc. Record patterns have this knowledge implicitly defined there, like that the name, the accessor is named like this, and X and Y with parentheses, and the construction of classes will help the authors to write better APIs. So look what's happening now. We can talk about pattern matching. We can talk about all the future directions of pattern matching. Constant patterns, like to say point of 1,2. We can talk about
actually
exceptions.
we can't. We don't have the time.
Okay, we can't. So all these topics help us to write better code.
Yeah.
But this future development about trying to express deconstructability for classes is going to help us writing better APIs from now on.
Oh, okay. So that's like you're saying there's like a switch of perspective there.
Exactly.
So the code is I'm writing on use side. You say that already got easier.
Yes.
But you're saying that the code that I write for others.
Exactly. And now the final part is composing two composable parts. Which are the composable parts? Composing construction and deconstruction.
Okay.
With reconstruction, like
with the withers.
Yeah, with the withers.
So, but I got a question about the deconstruction. Maybe we can get that out before we have to close down. But the intention cannot be that we write deconstructors for all classes, right? Because like some classes just don't want to be taken apart. They want to, guard their internals, encapsulation, all that good stuff. So the idea is not that every class that has
no,
okay.
Very good point. Not every class, not every. But if you wanted to participate in data extraction of some way.
So this is like a data-centric kind of class, but
yes.
maybe I want to have
yes.
something that doesn't align with records, like a record
or extra logic during extraction of data.
Yeah, good point. Because also their records are kind of like just doing the simplest thing.
Exactly.
Okay. Yeah.
You may want to. Now this goes in the territory of representation. If you put 2 ints inside, maybe you want to extract 2 ints, but maybe you have encoded them, I don't know, differently inside the class.
Oh, okay.
So this is also a representation.
All right. So if I have a class, like I think money is a good example because you usually want to so you just have like a long maybe that is the cents.
Yes.
But you want to have the fiction that it is euros and cents or dollars and cents.
Yes.
Okay, so then the deconstructor would then also deconstruct into full euros and the remaining cents.
Yes.
So even though internally I just have a single long that has like.
Okay, that's a possibility. So that's a possibility. We have a deconstructor, like to introduce it like a little bit more the principled way. Like we have a constructor that has the same name as the class and a bunch of parameters. The deconstructor has the same name as the class and bindings, so that will be returned at the pattern.
Probably. Because like you're not schooled like yet. You have to always hedge these things. You can't just say it will be like that. It is like
it's a possible future. It's a possible future.
Yeah. Nice. Thank you very much, Angelos, for being here.
Thank you for inviting me.
If you want to learn more about that, he's going to give that talk that aforementioned. So it's going to be on the Devoxx channel. It's also going to be on the Java channel, whichever is more comfortable for you guys. And I'll see you around tomorrow morning at 10 a.m. European time and 8 a.m. UTC to talk to Alan Bateman about changes and updates on virtual threads, specifically when it comes to pinning, synchronization, capturing, maybe file I/O. I hope I can pull some info out in there. Yeah, once again, thank you very much to you. And
thank you very much for inviting me.
Yeah, see you around. Bye.
Bye.